Okay, so let's do something this morning. Good morning, everyone. I want to look at the application of integration to kinematics. Application of integration to kinematics. Basically, kinematics is a branch of mechanics in physics that deals with the study of motion without regarding or describing the force that causes this motion. So whenever you study motion, but you do not pay attention to the forces that actually make this or cause this motion, that branch of mechanics is called the kinematics. It's called kinematics. Alright. So in kinematics, we'll be looking at displacement, velocity, and acceleration. Displacement, velocity, and acceleration. What is the definition for velocity? Velocity is the rate of change of displacement with time. Acceleration is the rate of change of velocity with time. While displacement is the what? The distance traveled in a specified direction. All these are vector quantities. For displacement, the unit is what? Meters. For acceleration, the unit is meter per second square. And for velocity, the unit is meter per second. Okay, now let's see something. So we use S of t to denote our displacement with respect to time, and V of t to represent our velocity, and A of t represent our acceleration. So in differential calculus, we know that to get our velocity, we have to differentiate our displacement with time. So V of t equals to ds dt. While acceleration, we have to differentiate our velocity, dv dt. Okay? Or in another way around, we can say that acceleration is the square s over dt square, meaning you differentiate displacement twice with respect to time. Differentiate it twice. Okay, now how do we apply this in integration or to integration? Okay, so given that our v equals the s over dt, to get this our s back, s becomes the integral of v dt. The integral of v dt. That means you have to integrate velocity dt plus your constant c. Don't forget your constant plus your constant c. Also, to get our velocity, also we know that acceleration equals to what? Dv dt. So to get our velocity back, so velocity equals v equals to what? The integral of a dt. It means to get your velocity, you have to integrate your acceleration plus your constant. Don't forget this is very, very important. Very, very important. So you'll be coming across with a lot of problem or questions that says a body starts from rest. What does it mean? When a particle starts from rest, it means that the initial velocity v equals to 0, and when v is equal to 0, the speed is equal to 0, it means the time t is equals to 0. Alright. When they say at the origin, it means if a body starts from the origin, it means it has initial displacement, and usually that at that time it is equal to the constant. So you have to, anytime you are integrating, always add your constant. Because the constant will give you the initial condition. Okay, give you your initial condition. So let's do something. Okay, let's solve this question number 1. A particle moves along a straight line with acceleration a of t equals 6t minus 4. Find the velocity of the particle at time given that its velocity is 2 meter per second when t equals 1. Okay, we are looking for find the velocity, so we are looking for velocity. So let's go back to our, okay, we know that a equals to dv dt, right? So our v will be the integral of a dt, integral of a dt. Okay, but what is our a? Let's go there. What is our a? A is what? A of t equals to what? 6t minus 4. 6t minus 4. So we're going to put this way. So v equals to the integral of 6t minus 4 dt. 6t minus 4 dt. Alright, so v equals to the integral of 6t minus 4 dt. So let's integrate now. So v equals, what do we do? We say ct squared over 2 minus 4t over 1. 4t over 1. Okay. So we have our 6 divided by 2, which is 3t squared minus 4t plus what? Our constant c. So our constant c, we have to put it there. So this is our v now. So v equals to this function. V equals to this function. Alright, so the question still continues. They say find the velocity of the particle at time given that its velocity is 2 meters per second when t equals to 1. So let's impute our initial condition. They say velocity is 2 meters when t is equals to 1. Let's go there. So we have our velocity is 2 at time t equals to 1. So we have 3 into 1 square minus 4 times 1 plus our c plus c. Okay, so we're going to have 2 equals 3 minus 4 plus c. 3 minus 4 is minus 1. Take minus 1 to the other side, we have 2 plus 1 equals to c. So our constant c equals what? 3. So our constant c is 3. Okay, we have known the value of our c, which is 3. So we have to find the velocity of the particle. Let's find the velocity of the particle now. Alright, so our velocity now becomes v equals to 3t squared minus 4t plus our constant c, which is what? 3. So this is our velocity at this time. Alright. Okay, let's look at the next question, number 2. Okay, maybe let's do number 3. A particle has velocity v of t equals to 3t squared minus 6t plus 4. Find the displacement of the particle from t equals to 0 to t equals to 3 seconds. The particle has a velocity v of t equals to 3t squared minus 6t plus 4. Find the displacement of the particle from t equals to 0 to t equals 3 seconds. Okay. Again, we know that velocity v equals to ds over what? Dt, right? So s will be the integral of v what? Dt, the integral of v dt. So what is our v? The integral of v, what is our v? Let's go back.